Hello everyone, welcome back. Today we will solve problem 46 in DeepML, which is called implement precision metric. So in this problem, we're given two lists. One of them is called yTrue and the other one is yPred. And what they're supposed to represent is the labels of elements in a binary classification task. So yTrue is going to be the true labels and yPred is whatever our model predicted. So what we want to do with that is we want to calculate the precision of this model. And in case you forgot or you're not been exposed to that, precision is the number of positively labeled elements which were actually positive. That is the number of true positives over the sum of true positives and false positives. So in case you forgot, or if you're a beginner, true positives are elements that where the true label is positive, that is 1, and were labeled as positive. Here we have 1. We have 3 of those cases here. The first element, the last element, and the second one. Second, if we're 0 indexed. And excuse me, the false positives are the number of elements which were labeled as 1, but were actually 0. And in this case, we have 0 of them. So this video is going to be tailored towards beginners. I'm not going to spend a lot of time talking about what the precision means because I covered that in a previous video. But I'm simply going to show you how you can solve this problem. And the official solution uses NumPy, and I think using NumPy is great. It's most likely what you will use in real life. But if you're just starting out and things are somewhat daunting and it's not that simple to work with, or if you're not that familiar with Python, I'm going to show you a different way in which you don't have to use NumPy and it's still going to work. And also, I'm just going to talk a little bit about why it is that I'm choosing to do things the way I choose to do so. And I'm going to show you what happens if you do it differently. So again, this video is tailored towards beginners. If you are a seasoned veteran, this problem should pose no challenge for you. So, but I think it's very valuable for beginners because I'm going to show how I would tackle this problem, doing kind of an overkill approach, talking about each step, and that is very valuable when you're starting out. So, as I've said in this channel multiple times, whenever it is that we want to calculate a fraction, my personal preference is to calculate the numerator and denominator separately and then just make the division. In this case, we have that our formula, precision, depends on 2 different variables, true positives and false positives. So what I'm going to do is I'm going to first calculate each of those metrics separately, and then I'm going to divide them. And then I'm going to generate the formula. So as I said here, a true positive is when the value here equals the value here. So what we would do in a nutshell is we're going to traverse through both arrays and figure out which entries match with one another. Now, you could do that with a for loop, and that's perfectly fine. It's going to work. It's going to pass all the test cases. I'm going to show you how to do it with a list comprehension. And a list comprehension is just a simple way to do a for loop, but it's just faster, it's more Pythonic, and I personally like it more because it's less clutter, it's less lines of code. And so this is going to work, but again, if you do it with a for loop, don't be surprised, it's going to work anyway. So let's talk about those list compressions. So we're going to generate a number that is true positives. This has to be a number, it's going to be an integer, which is going to represent how many times we have a true positive in our data set. So now, if you're not very familiar with the structure of a list comprehension, there's many ways you can do this, but if you have a conditional, because in this case, we're going to have a conditional, we're comparing 2 elements and we want to see when they're both equal, then you have to write it like this. You write the expression, then you write your if statement, that is which statement has to be evaluated to true. So this value, so the element in the list takes the expression value that you have defined here. If not, then you're going to put another value, for in this case, it could be 0, and then for whatever it is that you're traversing. So this may sound more complex than it is, but let me show you with an example. So how many times do we have to iterate if we were to do this with a for loop? Well, we would have to iterate n times, where n is equal to the length of this array. So what we're going to iterate here is going to be for I in range n. That's a simple for loop, nothing too scary. Now, what is the condition that we're trying to evaluate? Well, for a false positive, what we care about is that the value in the true label equals the value in the predicted label, and that all of those equal 1. So what do I want this list to represent? when that condition holds, well, I want that to equal 1. And so what this is going to give us in the example that we have here, if we were going to copy that same thing, we'll get 1, 0, 1, 0, 0, 1. Why? Because here they match and they're equal to 1. Here they don't. Here they match, but they're equal to 0, so we get a 0. They match again, they're equal to 1. Here they do not match, so that evaluates to 0. Here they match and equals 0, then that's 0. And here they match and they're equal to 1, so we get a 1. So that's what we're getting underneath the hood. But you may be thinking, okay, that's fine, but what we care about is a number. We don't care about which specific observations are evaluated to 1 or 0. What we care about is the number. And you would be right. So here, what we can do is we can take a sum. So what this is going to do is it's going to look at this list and it's going to sum. Basically, it's going to count how many times we have a 1 occurring here. And so that's going to, in the example that I told you about, that's going to evaluate to 3, and it's going to be the exact number of true positives that we care about. Now, for the false positives, we're going to do something somewhat similar. I'm going to copy the code here, but the condition that we care about now is different. So instead of having both of them equal 1, what we care about is that the true label is 0 and the predicted label is 1. That's why it's called a false positive. You're evaluating that as a positive when in reality, it's not. It's a negative. So this is the condition that we have to fulfill. And again, we're taking sum because we care about the number, not which specific examples evaluate to that. So after we do all that, the return, the precision metric, is just true positives over true positives plus false positives. And if we run the code here, we have to wait a little bit, but it's going to pass all the test cases, and that's it. We solved the problem. So that's it. Very straightforward. The official solution uses NumPy. I prefer to do it this way. Nothing against NumPy. I just wanted to show you a different way to do it, especially if you're a beginner. Now, one last thing that may be relevant in case you're starting out, and in case you only cared about how to solve the problem, you can tune out now. But a list comprehension doesn't always need to have both the if and else statement. You can just compress everything within one statement. So in this case, we could do something like this. We can do something like this. So we can say y true equals yy pred 1 equals 1. And so what I'm going to do is I'm going to print this statement, and I'm going to talk a little bit why it is that I wrote it differently if I could have saved myself some trouble and just written it this way. Now, you see that the test cases fail. That's because the way it's working underneath the hood is comparing print statements. In this case, we don't really care about that. Or rather, it's not expecting a print statement, so that's why it's failing. But it's pretty much the same code. So as you can see here, the result of this list comprehension without the 1 and the 0, without these conditional statements, is just booleans: true, false, false, true. So it's telling you when does this condition work and when it doesn't. Now, check out what happens if I substitute it here. If I substitute it here instead of my other formula when I'm calculating the true positives. If we wait a little bit, and this may come as a little surprise for you, now we're passing all the test cases. So you may be wondering what the hell's going on, because you're doing a sum. So how are you summing booleans? Well, in Python, and I think in other languages too, and I'm just saying that because I'm sure that some of those who are closer to the hood may not necessarily do this, but when you're trying to do a sum or an operation with booleans, it's going to evaluate true as 1 and false as 0. And so you could have saved yourself some work if you just written it this way. Now, and that's perfectly fine. As you can see, you pass all the test cases here. But why did I not do it that way? Well, apart from the pedagogical purposes, the reason is because what we cared about was numbers. We didn't care about booleans again. We wanted to do operation with numbers. And if you didn't know how Python worked with these boolean things, you may have been surprised that this thing worked. You might have thought that you necessarily have to do it this way. I think it's better to do it as I did originally, what I have highlighted here, because it's a best practice. If I'm reading your code for the first time, I would look at this and say, okay, you're doing a sum and you're summing 1 when the condition holds, 0 when not. So you're basically counting how many times the condition holds. If I look at this thing above here, I'm not entirely sure. Some people you may be working with are not that familiar with Python. They come from other languages backgrounds, or not even it's not even about Python, it's about how clear it is. So again, why am I doing this drawn out example? I just want to say that although sometimes you can write things in different ways and you can take advantage and push the boundaries of what it is that your language can do, sometimes it's not the best idea because you're losing a lot of clarity when you do it this way. And so you have to think not only about whether your code works, but whether the people you're working with can understand your code without you having to explain it to them. So that's it. That was my tangent, but I think it's worth it. And this simple problem provided a great space for me to talk about that. Anyway, see you in the next one. Happy coding.